Welcome to Lecture 1 of Module 10, in which we will study cognitive architectures. We have 4 learning goals in this module, so that by the end, you should be able to describe the 3 paradigms of cognitive science, explain the characteristics of a cognitive architecture in each paradigm, identify and describe the main components of a hybrid cognitive architecture, and sketch the design of 2 specific cognitive architectures, Isaac and Cram, and explain how they work. In this lecture, we will identify the main characteristics of a cognitive agent. We will explain exactly what a cognitive architecture is and how it works. And we will examine the 3 paradigms of cognitive science: the cognitivist paradigm, often called the symbolic paradigm, the emergent paradigm, and the hybrid paradigm, combining the cognitivist and the emergent. The main characteristic of a cognitive agent is that it can act effectively when it is pursuing goals, even though it is working in a world where there is uncertainty, even though the tasks may not be completely specified, and even though the world is continually changing. And it can do it while cooperating with other cognitive agents. To accomplish this, the agent constructs models of the way the world works, and it uses these models to predict the need for actions and to predict the outcome of the actions. We refer to this ability as prospection. Ideally, the agent continually updates the models, learning and improving its importance. So, a cognitive architecture is how we specify what is needed to do all this. A cognitive architecture, then, is a software framework that allows us to integrate all the components required for the agent to act effectively. This means we need to identify the formalisms, that is, the theories we use, for all the processing and knowledge representations used by the agent. This means the cognitive architecture integrates into a single system all the different core cognitive abilities: the ability to perceive, to pay attention to the things that matter, to select appropriate actions, to remember what it needs to perform these actions, to learn, to reason based on what it knows, to reason about its reasoning, and we call this meta-reasoning or metacognition, to anticipate what will happen in future, and we call this prospection. This allows for the agent to act or behave in a flexible manner, and to use the current context to guide its behavior. It also allows it to use prospection to identify what it should do to achieve its goals and guide the action as it's doing it. And finally, it should get better at what it does over time. It should develop, and it should do this on its own autonomously. As we said, there are 3 paradigms of cognitive science: the cognitivist or symbolic, the emergent, and the hybrid. The term cognitive architecture was invented by one of the pioneers of cognitive science, Alan Newell, working in the cognitivist paradigm, and it was borrowed by the other paradigms. A cognitivist cognitive architecture is a candidate unified theory of cognition. This is a theory that covers all the bases, from attention to learning, from all relevant perspectives, including psychology, neuroscience, and computer science. This is an idea introduced by Alan Newell in his book, Unified Theories of Cognition, in 1990. And here's a picture of his proofreading notes 3 years before the book was published. A cognitivist cognitive architecture, then, is a hypothesis about the aspects of cognition that are relatively constant over time, relatively independent of the task currently being carried out. This means that the cognitivist cognitive architecture is a generic computational model. It isn't tied to a specific domain or a specific task. The domain and task information is provided by knowledge. And when you add the knowledge to the cognitive architecture, you get the complete cognitive model. The knowledge is typically provided by the person who designs the cognitive system. Increasingly, the cognitive system acquires knowledge on its own through learning. Cognitive architectures are often depicted as diagrams showing how the various modules are connected. However, a cognitive architecture must also identify what formalisms, or computational theories, provide the foundation of its representations and the processes that operate on those representations. Switching now to emergent cognitive architectures, the emphasis changes. Here, the focus is on development, from a primitive state with very limited cognitive abilities, progressing through different stages where increasingly sophisticated cognitive abilities emerge, building on the previously developed abilities. Development depends on both exploration by the individual. This is the approach associated most with the work of developmental psychologist Jean Piaget, and social interaction. This is the approach associated most with Lev Vygotsky. These are complementary mechanisms. Typically, you need both. Stating this in more technical terms, an emergent cognitive architecture is the phylogenetic configuration, or phylogeny, of the cognitive system before it starts developing. The process of development is referred to as ontogenesis or ontogeny. So, the emergent cognitive architecture provides the innate skills and core knowledge required to bootstrap development, and it provides the structure in which the different cognitive mechanisms are embedded and developed: perception, action, adaptation, anticipation, that is prediction or prospection, and the motivation that drives the development. An emergent cognitive architecture, then, is focused more on the developing skills than on acquiring knowledge. Skills that use anticipation, skills that are adaptive, and skills that are used to maintain the autonomy of the cognitive agent. And because the body of the cognitive agent has an impact on what skills can be acquired, it also focuses on the shape, the kinematics, and the dynamics of the agent's body. That is, the agent's morphology. Since the body plays an active role in cognitive processes, the emergent approach rejects the idea that the mind and the body are completely distinct. We call that dualism. It also rejects functionalism, the idea that cognitive mechanisms are independent of either the computational device or the robot morphology. These are referred to as computational functionalism and robotic functionalism, respectively. A hybrid cognitive architecture attempts to integrate both the cognitivist and the emergent approaches. Typically, this means that it has both symbolic and sub-symbolic representations and processes. All cognitive architectures specify the modules and their connections, as well as the formalisms for knowledge representation and algorithmic processing. Cognitivist cognitive architectures focus on knowledge, the memories to store and recall that knowledge, the formalisms for learning knowledge, and some way of programming knowledge into the architecture. On the other hand, emergent cognitive architectures focus on development and provide the agent's phylogeny, the basis for development, including innate skills and core knowledge, as well as the memories to store and recall knowledge and skills, along with formalisms for development and for maintaining the autonomy of the agent. To summarize, the chief characteristic of a cognitive agent is the ability to act effectively in pursuing goals in an uncertain, incompletely specified world. A cognitive architecture is a framework that integrates all of the elements and core abilities of a cognitive system. It dynamically recruits these elements so that the agent exhibits flexible, context-sensitive behavior and prospective selection and control of its actions. A cognitive architecture specifies the formalisms for knowledge representation and processing. And there are three types of cognitive architecture: cognitivist or symbolic, emergent, and hybrid. Here is some reading. And here are the references cited to support the main points in what we covered today.